Through this presentation, we are going to learn about the arrangement of resistors in series. In the series combination, the resistors are connected or joined one after the other. Now, as shown in figure here, three resistors R1, R2 and R3 are connected in series between the point C and D, such that one end of resistor R1 is connected to the point C and its other end to the resistor R2. The other end of the resistor R2 is connected to the one end of R3 and other end of R3 is connected to the point D. Now the ends C and D of the combination are then connected to the terminals of the battery through a key K. When the circuit is closed, the same current I drawn from the battery passes through each resistor R1, R2 and R3 because this is the only path for the current to flow. As the three resistors R1, R2 and R3 are connected in series in the circuit, hence V1, V2 and V3 be the potential differences of resistor R1, R2 and R3 respectively. Then we will have V is equal to V1 plus V2 plus V3 and we will call this as equation first. If Rs, where S is for series, is the effective resistance between the points C and D, then according to Ohm's law we will have V is equal to I into Rs, where Rs is the effective resistance between the point C and D. Then we will have V1 is equal to I into R1, V2 is equal to I into R2 and V3 is equal to I into R3. Now substituting all these in equation first, where our equation first was V is equal to V1 plus V2 plus V3. Hence we will have I into Rs is equal to I into R1 plus I into R2 plus I into R3. Being I common in this step, that will get cancelled and we will have Rs is equal to R1 plus R2 plus R3. And if n resistors are connected in series, then we will have effective resistance is equal to R1 plus R2 plus R3 plus dash 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 plus Rn. So through this arrangement of resistors in series, we have learned the following points: that the same current flows through each resistor. The effective resistance of the resistors is equal to the sum of their individual resistances. The potential difference between the two extremes of the arrangement is equal to the sum of the potential differences across individual resistors, and the effective resistance is larger than each of the individual resistance. And one very important thing, this arrangement is used to increase the resistance in a circuit.